Hi, so in this chapter we are going to talk about roots of functions, so let's get started. There are two main methods, the Newton-Raphson methods, so let's get started with it. A method for finding successively better approximation to the roots of a real-valued function, that's why it's good, starts with an initial guess which is reasonably close to the true root. Then the function is approximated by its tangent line, and the main disadvantage that for this tangent line we need the derivative, and sometimes it's very hard to calculate the derivative of a function. So this is the main disadvantage. So we have a recursive iterative formula how to calculate it, where f denotes the original function and f prime denotes the derivative of this function. And it's quite simple, I think. So let me show an illustration. We have a one-dimensional function and something like this, and we have an initial guess x0, and we just have to calculate the tangent line of our function, and it's going to be something like this. And where this tangent line intersects the x-axis, that will be the next guess. It's a bit better, as you can see. And we calculate the tangent line for this point too. And as you can see, we have to recalculate these derivatives over and over again. I mean, not always. The best approach is to calculate the derivatives at once at the start, and we just have to reuse it. So the tangent line is something like this. This will be the next guess. Then the tangent line is something like this. It's quite a good guess, so we consider it done. We consider it the solution. We don't make much error. Okay. A bit better is the so-called second method, a root-finding algorithm that uses a succession of roots of second lines to better approximate the root of a function. So we have two initial guess, we have 2 points, and we just have to connect these 2 points without the derivative. It's very important. So the second method can be thought of as a finite difference approximation of Newton's method. So we don't have to calculate the derivatives exactly. So this is the main advantage, because sometimes it's, as I said earlier, very hard to calculate the derivatives. So the order of convergence is the golden ratio. It is superlinear but not quadratic, so it's the exponent is between 1 and 2. So we have 2 initial guess, x0 and x1. We put dots to the functions at this parameter, and we just draw a line, and we find the point where this red line intersects with the x-axis, and is going to be the next point. So here we have 2 points. We just have to connect them and calculate the next intersection between the x-axis until our algorithm converges. And x4 is approximately a good result for our root, for our solution. So that's all about the second method. In the next videos we are going to implement it together and going to plot it.